Let's carry on with the file from our previous example and let's talk about solving a generative study. Now so far we've gone into edit the model and we've added some geometry for obstacles and we've looked at design conditions. We looked at constraints and loads. We set up our study in terms of the manufacturing method and design criteria. We applied a material and now we're ready to solve. In the generate section, we have a pre-check which tells us whether or not we have all the required information to solve the study. This doesn't necessarily mean the study will be successful, but it does mean that it has all of its criteria that it needs. There are some instances where we might have a yellow exclamation mark that tells us that there could be some problems but we can still solve, but if we're missing anything at all, it'll be a red X there. The next thing is the previewer, and this is a recent addition to the generative workspace. The previewer allows us to go through all of our criteria. It takes into account our preserve and our obstacles, and it looks at our loads, and it starts to generate essentially a boundary. Now, this is not going to be anything like the final. It's not going to give you an idea of what the shape is going to look like. But what it does tell us is whether or not we have maybe too much restriction with our obstacles, or maybe there's some other error that we might come across. So if we look at the previewer as it's running, we get an idea as to where it's going to try to generate the supports for the rear shock. Right? So you can see that there's some geometry in the middle. This potentially leads us to having an issue where we don't have enough shock clearance. So these are things that we need to sort of look at and account for. The previewer does not instantly give you a result. It doesn't instantly say that there will be material here. So at this point, I'm not going to worry about it. However, it is a good final check to make sure that we're at least in the right ballpark. So we're going to stop the previewer and we're going to go to generate. Now inside here, whenever we generate, we are going to be using cloud credits. Now, cloud credits will be 25 for us to solve one of our studies. Now this is the same whether or not we choose multiple manufacturing methods or if we alter our design criteria objectives. When we get to the stage where we're going to convert that outcome to something that we can work with, a BREP model, then it'll be an additional 100 cloud credits for each model that we export from our results. So at this point, we're ready to run. Let's go ahead and generate this one study. And one thing that's nice about the generative design studies is that we can actually watch the progress as it's happening. Once we start to see results in the Explorer, then we can actually watch each iteration as it goes. Depending on the specific geometry you're dealing with, the number of obstacles, the number of preserve regions, and generally the complexity of the model, you will see that some things can generate relatively quickly and some might take quite a while. We have a pop-up that tells us that the thumbnails for our outcomes will appear when processing. We simply need to close the job status. And as this is processing, it will again begin to populate these results. We're going to investigate the results in our next video. So at this point, we're going to let this process and we're going to come back and check in on it after it's done. Let's carry on with the file from our previous example and let's explore the results of our three material choices. This file has an aluminum, a steel, and a titanium, and you'll notice that one of the files is still processing. So let's take a look at what we can do inside of this Explore workspace, how we can filter our results, and ultimately pick one of the frames that's going to work for our design. The first thing that you'll see on the left side are some of the outcome filters. You can see that we have the synthesis method and manufacturing method, and there's only one choice here. But we can take a look at outcomes that were created already, we can take a look at ones that are processing, and we can use these sliders to filter by things like volume, mass, displacement, and factor of safety down here. What we really want to do is we want to explore some of the display options and ultimately take a closer look at these designs. The first thing I'd like to do is change my display to show a little bit more information. As we scroll down here, you can see that we have aluminum, 6061, steel, and titanium. This also gives us basic information about these studies. For example, the mass. We can see that the aluminum one is about 3.5 kilograms, while the steel one is 13. Both have the same factor of safety, but you can see the steel has a much smaller max displacement value of 0.92, where the aluminum one has a higher displacement value of 3.86. If we scroll down to the titanium one, you can see that the mass is 5.8 kilograms, which is slightly more than the aluminum. the max displacement is less than the aluminum, and the factor of safety is actually at 2. So while the factor of safety is at 2, it's still processing because it is still trying to converge to those values. Let's go ahead and let's select each of these, and we can select up to 4 results, and we can view them at the same time. So this way we can get a little bit closer look at what the geometry is like for each of these outcomes. Each one that's selected will give you the information displayed on the right-hand side, as well as the iteration number. We have the titanium version, minimum factor of safety, the mass and displacement, and when we select on outcome 2, you can see that we're looking at the steel version, its max displacement, its outcome, etc. We also have some options to do things like view stress. So if we want to focus in on some areas, you can see that we have low stress on our fixed mounting bosses, green, which is ideal, and then if we zoom into certain areas like around the steering stem or head tube area, you can see that we have blue and green in this area as well. We can also take a look at some of our obstacles and preserve regions by displaying them with opacity on the screen. If we want to decide on one of these to go further with, we can filter down and look at just one single study. For example, aluminum 6061. While aluminum 6061 is fairly light, it does have some issues that we need to address. And mainly the issue is max displacement of almost 4 millimeters. It's going to be a little too large for us. So what we want to do is we want to filter down the iterations a little bit farther. If we go down to iteration 50, this is a little bit further back in the study, you can see that our max displacement is dropped to 2.6 and the minimum factor of safety is still 2.01. If we go back even farther to iteration 40, you can see the displacement's dropped to 1.59, but the factor of safety is still at 2.03. Now this is changing the amount of material being used, so the volume of material and the mass are going up. In this case, we are at almost 8 kilograms. So there's a happy medium that we can find here in these iterations. If we have an acceptable displacement of about 2 millimeters, you can see that iteration number 47 gives us a factor of safety that's above 2, the displacement is around 2 millimeters, and the mass is around 5.5 kilograms. So this is a great option for us in terms of picking a final result. Because I'm happy with this, I'm going to select this option to output the outcome and create a new design. So while this is creating our new design and we're waiting for it, let's take a look at some more options inside of this Explorer in terms of filtering our results. Inside of here, let's take a look at the scatter plot view. With the scatter plot view, one thing that we can do is we can take a look at various factors like factor of safety in relation to, in this case, mass. So we're looking at aluminum, which has a factor of safety of 2. Well, really all of these are factor of safety of 2 because that's what we wanted to converge on. However, its mass is fairly low. And if we go over a little bit farther, you can see titanium has a slightly higher factor of safety and its mass is a little bit more. If we go even farther, you can see that the steel has a little bit higher factor of safety but a much higher mass. If we want to take a look at this in relation to some other factors, for example, volume. So if we want to look at the volume of material, you can see that aluminum and titanium are actually pretty close, while steel is quite a bit higher. We can also take a look at it in relation to max displacement. Now in this case, the displacement of steel is quite a bit lower than titanium or aluminum. So as we look at these designs, there are various ways that we can really look at all the results and figure out which is going to work best for our ultimate design. We're going to go to our table view, and again, this is just another way to filter the results. Back in our properties view, this is the best option that gives us the most amount of material very quickly on the screen if we need to look at all of these values at the same time, such as the displacement, the mass, and the factor of safety. You can see the small icon in the left corner. This tells us that this is a design that we're using to output into Fusion 360's design workspace. And there's an icon that tells us which iteration we're looking at. As soon as this icon preparing a new design turns green, we'll be able to open this design inside of Fusion 360. But as we're looking at the design inside of our Explore workspace, I want to talk a little bit about the usage case for generative design in terms of this motorcycle frame. Because we are looking at an unrestricted manufacturing method, we're not looking at CNC machining this design, we're not looking at doing a large 3D print in metal of this design. We're ultimately using generative design for one of its intended use cases, and that's to help drive a final design's geometry based on the results here. So ultimately, with this frame, ideally we would use what we learned here in generative design as well as the geometry that gets outputted in order to create our final frame using traditional manufacturing methods, potentially using additive manufacturing or some other manufacturing techniques. Because it's generally not feasible to print a part this large, we would have to look into casting, maybe look into some alternative manufacturing methods. That's not to say that all cases will follow this same model. There are many instances where we can generate an output that's designed for additive, or it's designed for CNC milling, or even this unrestricted method, and produce that part right away without any alterations to its geometry. It really just depends on the end use case and what you're trying to design. So again, once our preparing a new design icon turns green, we'll open that in Fusion 360 and we'll explore the results and understand the geometry that gets created.